For the purposes of game design, we can simplify the applications of game theory to 4 components: players, actions, payoff, and information. These core components are then the basis for the full set of rules for a game. First, we must define the players. For this discussion, we will assume that players are competing against each other and not playing a cooperative game. As a player, they will assume that they are playing by the same rules as everyone else playing the game. That is, they have the same goals and strategies available to them, or at least a balance of resources and goal objectives. Game theory shows us that strategies change as more players are allowed to participate. Team Fortress 2 is a great example of how having more players changes the strategy of the game. In the Team Fortress 2, players can select different characters to play with different strengths and weaknesses. The more of these roles that are utilized by the players, scout, soldier, medic, and etc., the more strategy options the teams will have. Payoff is next. The payoff for playing a video game is subjective, but generally involves a sense of self-accomplishment or entertainment. Remember, players are likely to experience some defeat and frustration, so there must be some intrinsic value to the art of playing a video game in itself. As game designers, we manipulate this concept of payoff constantly in an attempt to achieve flow and fun. So what is the payoff for completing a game like Halo? Satisfaction in completing the story? Technical skill mastery? How about a game like World of Warcraft, where the game never really ends? As game designers, we can certainly create endings to games. The payoff is something more often something each player decides for themselves. Actions define what a player can do and when they can do them. Games usually structure decision points where players will make choices. A common decision point in video games is a turn. That is, players each take a turn to declare decisions and take actions. Decision points can also be freeform or simultaneous, which again sets up a whole new set of strategy paths and outcomes. Real-time strategy games, such as StarCraft II Wings of Liberty, are perfect examples of simultaneous gameplay, while the Heroes of Might and Magic series utilizes turn-based actions. Our last component is information. What does each player know as they start and play through the game? And what do they not know? Remember, in the prisoner's dilemma, the information the accused had was crucial to how they approached the problem. They both knew all the choices available to the other, but they did not know the decision on those choices the other would make. Changing any information, however, has a huge effect on the game. If the prisoners have faced similar plea deal and know the previous outcome for testifying was less than optimal, that knowledge might play an important role in the decisions they make the next time the scenario is presented. Consider chess. All players have equal access to information. They know every move their opponent may make in perfect clarity. Now compare that to a game like an RTS, where elements like real-time actions and fog of war can limit the opponent's information of the other player's actions. It is not to say one is right or wrong, only that game theory teaches us that the level of information available to players changes the gameplay in striking ways. Together, these essential components and the variations they can form help game designers balance their games. These components combine to create a stable platform for games that can be functional and predictable. Yes, predictable. As game designers, we do want some predictability. We don't want the game to be an exercise in predictability to the point of pointlessness, but we do need a certain amount of it in the rules so the game has stable structure. Players expect a level of consistency as they replay games over and over. As we have seen, game theory wasn't conceived for the purpose of making video games, but the concepts are a perfect match. From the simplest form of zero-sum games, we can take and expand game theory to match the design strategies for most video games. Variety in games stems from how these concepts are presented, altered, or combined. We should be noticing a lot of crossover in these game theory concepts at this point. So in this topic, we will look at some game theory concepts and how they are applied to popular video games. When we talk about asymmetric versus symmetric game design, we are talking about the different methods of achieving balance in gameplay. A symmetric design gives all the players the exact same skills and resources. There is zero difference in the actions one player can take over another. Games in the Halo series fit the symmetric design. Each player moves at the same speed. Each player can take exactly the same amount of damage. And each player has the same access to the same set of skills and game options. In doing this, the designers have created a perfect balance among players, at least in the sense of potential player versus player scenarios. Only skill at manipulating the controller separates one player's advantage at the game from another. Asymmetric games also seek to ultimately balance player versus player, but still offer some variety in playable characters. For most games like this, the skills and abilities of a player character are a series of benefits and trade-offs. Let's look at Team Fortress 2 as an example of asymmetric game design. In Team Fortress 2, each character class is slightly different. Some are faster with a trade-off of having fewer hit points. Some have more powerful weapons with a trade-off of being bigger targets. There are many combinations of benefits and penalties, but ultimately there is still balance. In essence, each benefit has a certain value that is countered by an equal penalty. This allows for many methods to victory while maintaining a fair and balanced experience. With the rise of the internet came massive multiplayer online gaming and new ways to create games that are both cooperative and competitive on a grand scale. In general, cooperative games are games where people work together to find solutions to victory, and competitive games are games where they work against each other to win. In cooperative games, it is possible for all players to lose the game or for all players to win the game. While not a dedicated cooperative game, World of Warcraft has many cooperative elements. The best example in the game's boss raids, where perhaps dozens of players will gather with one goal in mind: defeat the boss or die trying. In this scenario, all players must coordinate their attacks together for an all-or-nothing fight to the finish. If the boss is defeated, everyone shares in the victory. If the boss is not defeated, everyone shares in the loss. Most games, however, are designed to be competitive. Someone or many players will win and the rest will lose. There are countless examples of this premise, such as many sports games or any game with player versus player elements. It is these types of games where game theory becomes so relevant and important in terms of creating strategies in the game that are balanced and yet not exercises in pointlessness. Zero-sum games are ones in which one player's gains are directly related to another player's loss. Some zero games provide what is called perfect information. That is, all players know all of the actions of the other players. While not strictly a video game, chess is a perfect example of zero-sum game, where players have a perfect knowledge of the other player's actions. Zero-sum games without perfect knowledge could include many real-time strategy games, where one player's knowledge of the other player's actions may be limited by certain factors, such as a fog of war or a lack of directly witnessing all of their actions. Extremely simple games such as rock, paper, scissors are also good examples of zero-sum games without perfect knowledge, because the actions of all players are simultaneous and no one can accurately predict what an opponent will do. In addition, victory conditions are clear to all players in a single universal solution to achieving the goal of winning. On the opposite side of the coin are non-zero-sum games. In these games, there are no universally obviously accepted solutions to winning. In many ways, non-zero-sum game theory operates more like real-life scenarios, so it makes sense that games that utilize non-zero-sum game theories are most likely going to be real-life simulations, such as SimCity. Pen and paper role-playing games are the best examples of non-zero-sum game theory. Players cooperate. They are not limited by a given set of solutions, and the imaginary resources they can draw upon to solve the problems are effectively endless. There are huge differences in gameplay when players take turns than when everyone takes simultaneous actions. In game theory view, it is the difference in information available. In simultaneous games, information is constant, but a player must manage their own ability to take actions with their ability to track the actions of opponents. In a turn-based game, players can stop and examine game information at a more relaxed pace. Many games use what is called a turn-based system. Each player gets a turn to examine the known information and take actions in the game. Once a player takes all the actions they want or can, it is the next player's turn to do the same. Heroes of Might and Magic games are excellent examples of this. So is chess. Fighting games are good examples of simultaneous game theory in action. Each player chooses an attack or defensive move without any knowledge of what the opponent will do, and all its decisions are made at the same time. It is the sort of like playing rock, paper, scissors, but with many more possible combinations. Knowledge of what other players have done becomes relevant to what they will do next, and there is no way of knowing what they will do next. These are games of action and reaction with little time to ponder prior knowledge. What players know is an important aspect of any video game structure. Having access to certain knowledge changes gameplay as that knowledge is added to or reduced. In game theory, this is divided into perfect knowledge and imperfect knowledge. Games with perfect knowledge mean that all the players not only know the game structure and the rules, they also have complete information of all the events in the game that have previously occurred. For instance, in a game of chess, each player is witness to every move their opponent makes, and that makes it a perfect knowledge game. The Heroes of Might and Magic series is a good example of game of imperfect knowledge. Even though players take turn, the players do not see what the opponent is doing. They may see the results of their strategies when their armies appear out of the fog of war, but they do not see the entire strategy or all the actions the player is taking to claim victory.